climb the mountains and get their good tidings. Nature's peace will flow into you as sunshine flows into trees. That's John Muir. Beautiful words about mountains. But what if those mountains start sending a different kind of signal, maybe more of a warning?
That's exactly the situation we're looking at with Kanchenjunga. It's not just, India's highest peak. It's revered deeply in Sikkim and Nepal, a deity. And now from the Sikkim side, there's this visible blackening, a gray tinge. It's troubling.
It really is. It feels less like scenery changing and more like an alarm bell from, well, one of Asia's most critical water sources. Welcome, everyone, to The Deep Dive. This is where we take complex info, strip out the noise, and really focus on the essential understanding.
And today, we're laser focused on this observation, Kanchenjunga turning black. We're drawing heavily from a NewsClick report, which pulled together insights from a whole range of experts, glaciologists, climate scientists.
Environmental consultants, even a mountaineer's firsthand account.
Right. So our mission today is pretty straightforward. Unpack why this is happening according to the science, what the knock-on effects are culturally, environmentally, and crucially, why this specific mountain showing this specific sign matters so much right now.
And for you listening, especially if you're grappling with topics for, say, the UPSC exams, environmental geography, climate change, disaster management, these are all key areas. Or if you just want to be informed, the insights here are vital. We're essentially distilling that expert analysis for you.
Okay, so let's start with the trigger, what people are actually seeing. NewsClick reporter saw it from Upper Pelling in Sikkim, this noticeable blackening or graying on the mountain slopes.
And we should remember, this is the third highest peak globally, India's highest.
Yeah.
Hugely significant culturally. Summiting from Sikkim is actually prohibited out of respect. So this change is happening on a peak that's both a natural icon and sacred ground.
So the immediate question is, all right, we see this change. What are the scientists saying is actually causing it?
This brings us to experts like Manish Mehta from the Wadia Institute of Himalayan Geology. He confirms what we broadly know. Himalayan glaciers are retreating. But the rate, well, it varies wildly, sometimes just 6 meters a year, sometimes maybe more than 20, even 25 meters.
And it's not just shrinking in length, it's losing mass. He talks about losing about 0.3 to 1 meter of water equivalent per year across most of the Himalayas. Think of that as like shaving off a layer of ice up to a meter thick each year if you melted it down.
He does mention the Karakoram range is a bit different. Some glaciers there are actually stable or even surging, which is interesting.
But Kanchenjunga isn't in the Karakoram, it's in the eastern Himalayas. And that region, well, it's retreating faster.
Right. And Mehta's explanation for why is really key. The eastern Himalayas get most of their snow from the Indian summer monsoon. But as temperatures warm up, the rain line creeps higher up the mountains. So less area gets snow, more gets rain.
Exactly. And they get less winter snow, too, from those westerly disturbances that bring moisture across in the winter. So less snow overall, particularly the dense winter snowpack, makes them, more vulnerable when things warm up.
Okay, so less snow cover, faster melt. How does that translate into this black appearance? Mehta points to basically two things happening based on the sources. First, as the snow and ice melt back, it simply exposes what's underneath, the rock, the dirt, the debris that's naturally dark.
And second, you've got stuff being carried by the wind, dust, tiny rock fragments, but also pollutants like soot from smoke, black carbon.
Yeah.
It all gets deposited onto the ice surface.
And this is where it gets tricky. It creates a feedback loop. Clean snow and ice are really reflective. They bounce sunlight back that's high albedo. But dark rock, or ice covered in dark dust and soot, that absorbs sunlight. Low albedo.
Right, so the melt exposes dark stuff or dark stuff lands on the ice. Either way, the surface absorbs more heat from the sun, which of course makes it melt faster.
Leading to more exposed dark surfaces or more concentrated dark particles?
Exactly. It's a vicious cycle.
Yeah.
And if you don't get enough fresh, bright snow falling to cover it up again, that blackening just becomes more and more apparent, and the melting accelerates even more.
So beyond just how it looks, this constant loss of ice mass has some really serious, immediate consequences, particularly for safety on the mountain.
Yeah, Mehta really stresses the hazard part. As the glaciers melt unevenly and shrink, these huge cracks, crevices, and even fault lines can open up on the surface.
Which makes climbing, as he points out, incredibly dangerous and technically very difficult. He apparently emphasized how critical a good snowfall season is for the coming winter. Without enough new snow to sort of bridge those gaps and stabilize things, the mountain could stay hazardous for years.
And it's not just theoretical. We hear from Piali Basak, a mountaineer who was on an expedition coming from the Nepal side. She saw it firsthand. Areas that used to be covered in snow and ice were now exposed rock.
And she talked about the practical difficulty. Seeing these crevasses more clearly because the rock was dark, but finding them impossible to cross safely. She even mentioned her crampons, those iron spikes for boots meant for ice, were actually a hindrance on the hard, bare rock. It really paints a picture of the terrain changing underfoot.
This specific observation on Kanchenjunga, it really slots into a much bigger picture, the global climate context. Kanggung Zhang from ICEMOD, that's the International Center for Integrated Mountain Development, he confirms, yeah, we're seeing intense, accelerating glacier melt globally. It's really picked up speed in the last decade.
And what he highlights, which I found fascinating, is that glaciers aren't just victims of warming, they're incredibly sensitive indicators. They react faster, more visibly than, say, sea level rise or big ecosystem shifts.
You can actually see the landscape changing within a human lifetime because of glaciers melting. It's not some abstract concept. As Zhang puts it, this melting is clearly a warning.
A warning getting louder. He's quite clear. This trend isn't stopping as long as temperatures keep rising. He mentioned an almost linear relationship, basically. Every bit of warming matters. More warming equals more melt. Simple as that.
But importantly, he also stressed that doesn't mean we're helpless. He said every effort to curb climate change will help reduce glacier melt. So while the trajectory is alarming, action now can still limit how bad it gets. It's not a lost cause.
And this is getting noticed internationally. Zhang points out the UN has declared 2025 the International Year of Glacier Preservation, and the whole decade from 2025 to 2034 is the decade of action for cryospheric sciences.
It shows there's growing recognition of just how serious this is. It's a call for everyone, scientists, governments, the public, even mountaineering communities, to work together on this.
Okay, so the mountain itself is changing, acting as a climate warning sign. But let's talk about the effects downstream. What does this mean for the millions who rely on the rivers fed by these glaciers?
Mrenmoy Chattaraj from Climate Trends really emphasizes this. He links things like the early, intense heat waves we've been seeing directly to impacts on Himalayan glaciers, warning about potentially devastating consequences for the ecosystems downstream and, critically, for the pattern of river water flow throughout the year.
He even connected these altered water patterns to disasters like the massive floods in Pakistan in 2022, noting that early monsoons, potentially linked to these broader shifts, played a role. That system is also fed by the Himalayas.
And this change in river flow, it's one of the most critical and maybe counterintuitive consequences initially. The experts cited agree. At first, as glaciers melt faster, you actually get more water flowing into rivers like the Ganga and Brahmaputra.
Right, which sounds good, but it's temporary. The report flags this crucial warning. This initial surge leads toward what they call peak water, a period where flows are highest, potentially increasing flood risks too, especially if rainfall patterns also intensify. Some estimates put this peak around the year 2050.
And here's the key part. After that peak, as the glacier reservoirs become depleted, the water availability starts to steadily decline. So you go from increased flows and flood risk, potentially, to a future scenario of more frequent and severe droughts.
That's a massive implication for planning. Regions downstream need to think about managing potential floods in the nearer term and simultaneously strategize for long-term water scarcity. It's a dual challenge.
Chattaraj also hammered home the point about amplified warming in the Himalayas. The region is warming much faster than the global average, he mentioned, figures like 2.2 degrees Celsius compared to the global 1.5 degrees.
And that faster warming directly drives faster melt, messing with the natural rhythm of the rivers, impacting reservoirs, irrigation, everything that depends on predictable flow.
And that feedback loop, again, the dark, exposed ice absorbing more sun, is really pushing this acceleration.
Yeah.
The numbers cited were stark. Comparing mass loss from 2002 to 2022, the loss in 2022 alone was apparently about 4 times higher than in the earlier years of that period. That's a rapid speed up.
The report also included local perspectives. People like Saurav Chakraborty and Mahendra P. Lama talked about the immediate regional impacts. Kanchenjunga is a massive tourist draw for West Bengal and Sikkim. The blackening is a visual symbol of a danger that could hit their economy hard.
And they drew connections, like how heat waves down on the Indo-Gangetic plains can actually impact how much snow falls up in the Kanchenjunga Basin in winter. It shows how linked these systems are. It's not just the mountain in isolation.
The direct water connection is undeniable. Rivers like the Tista, the Koshi, the Range, they all start here. They provide water for everything downstream, including, as the report mentions, about 7 hydroelectric plants just on the Teesta River alone. That's a lot of power generation reliant on this meltwater.
Plus, there's the threat of GLOF's glacial lake outburst floods. Remember the Lonak Lake incident? That's the kind of thing we're talking about. As glaciers retreat, they can leave behind unstable lakes dammed by ice or debris. If those dams fail, you get catastrophic floods downstream. It's another hazard that increases as glaciers shrink.
And the long-term picture painted is grim. A persistent black Kanchenjunga scenario, they warn, could spell potential catastrophe for the entire Indo-Gangetic Plains. It even raises questions about things like silt deposition needed to maintain the Sundarbans Delta. It points towards potential widespread disruption.
Bringing it all together, Anjal Prakash, who's a senior IPCC author and professor at ISB, really framed it as the final word. He called this accelerated melt a stark warning of the climate crisis gripping the Himalayas.
He described the Himalayas not just as mountains, but as Asia's vital water tower. It supports incredible biodiversity, yes, but also sustains hundreds of millions of people downstream. And that tower is being destabilized now by warming and erratic weather.
The message couldn't be clearer. This isn't some far-off threat we need to worry about later. The rapid melt, the blackening, it's proof climate change is unfolding now, as he put it. It's an immediate threat to water, food security, livelihoods.
And the call to action, echoing across all the experts cited, is urgent and twofold. Globally, drastically cut emissions. Regionally, invest heavily in climate adaptation. Build resilient infrastructure. Prepare for the changes that are already locked in.
Okay, so let's quickly recap the core takeaways from this deep dive based on that NewsClick report. The blackening of Kanchenjunga. It's a visible sign of faster glacier melt, driven by melting exposing dark rock and debris, plus dark particles landing on the ice, creating that feedback loop where dark surfaces absorb more heat.
And this whole process is accelerated by the fact the Himalayas are warming faster than average and seeing changes in snowfall, especially in the east.
Critically, this isn't just a local issue. Kanchenjunga's state is a highly sensitive indicator of global warming, a change happening fast enough for us to see. And it brings immediate dangers, like making the mountain itself more hazardous.
And the downstream impacts are huge. We're looking at a future likely defined by peak water around mid-century, potentially meaning more floods initially, followed by a long-term decline in water availability, bringing drought risk, plus the ongoing danger of GLOFs.
Understanding these connections, the science behind the blackening, its role as a climate bellwether, and these profound hydrological shifts, it's absolutely crucial. Whether you're studying for exams like UPSC, needing that deep environmental knowledge, or just trying to stay informed about the defining challenges of our time.
Exactly. This deep dive was about pulling out those essential insights from the experts for you. And maybe here's a thought to chew on based on those projections. If peak water is likely around 2050 with decline after, what does that really demand from downstream regions in terms of planning their infrastructure, their agriculture, their water use starting now?
It feels like a fundamental rethink is needed, doesn't it? Or consider this angle. Kanchenjunga is simultaneously this critical scientific benchmark for climate change and a sacred, revered deity. How can we bring those two aspects together? Can the scientific urgency, highlighted by things like the blackening, combine with that deep cultural reverence to actually drive more powerful, more holistic action for conservation and climate mitigation?
Really interesting points. We sincerely hope this exploration of the expert views on Kanchenjunga's situation has been valuable. If you found this deep dive helpful, maybe for your studies, maybe just for your awareness, please do consider liking and subscribing wherever you get your audio.
And absolutely, if you have more questions or thoughts you want to share on this vital topic, leave us a comment. We genuinely appreciate hearing from you and continuing the discussion.
Thanks for joining us on the deep dive.
Until next time.